What's up, YouTube? In today's video, we're going to be looking at an introduction to NoSQL stores. This is the part one of a series of videos I'm going to be making, I plan to make on Cosmos DB specifically, that is Azure or Microsoft Azure Cosmos DB. But before we can start there, I want to give you this introduction to NoSQL stores, the differences, and slowly introduce you to Cosmos DB. So probably in the next video, we'll go a little deeper into specialization on just Cosmos DB. All right. But today's video is the introduction. I'm going to introduce NoSQL stores by way of a comparison. That is the differences, not so much the pros and the cons, but just the differences between RDBMs and NoSQL SQL stores. I think that'll give you a good understanding of what NoSQL stores are or are not. And then we'll talk about a few different versions of or different kinds of NoSQL stores. And then in today's video, we're going to be looking primarily at partitioning, which is not necessarily specific to Cosmos DB. It's a concept or an idea that goes across NoSQL stores, but then focusing more on Cosmos DB itself. So even though the slide here is showing you, we are talking about indices and queries, I don't think we'll have the time for that in this video. It'll just get way too long and probably get way more overwhelming. So I think I'll do the indices and queries in the next video so that that'd be more targeted to, and we'll have about 30 minutes there. So I'm hoping to do this in about 30 minutes. Let's see how that goes. All right. So before we can look at the differences of NoSQL stores, let's look at the kinds of NoSQL stores, right? So there are the key value store. This is literally a key and a value. There's nothing much to it. There are a few popular databases, or well-known, and not necessarily popular, but well-known certainly, databases that fall into this category. There's Amazon's Dynamo was one of the first databases that came out of this category. Generally, just NoSQL stores. That's not to say the NoSQL idea was new at the time. It wasn't popular. It was known a few years ago, but Amazon came out with this Dynamo database that they started using for their own, not necessarily the cloud, but to run Amazon. And they published a white paper on this database, Dynamo. And many people picked up that white paper and started working on their things. Microsoft did the same. They took that white paper and they built Azure Table Storage as part of this idea. But Amazon Dynamo is a key value store. Redis is a key value store. React is a key value store. So these are examples of NoSQL stores that are key value stores. Now it so happens that Redis are like in memory. Amazon's Dynamo is not. It's an actual database that gets persisted or durable store. One could say that Redis is also durable, but they are key value stores. The next is document stores. So document stores are stores like MongoDB and Cassandra. Cassandra is from Facebook. MongoDB, I believe, is from the originator of DoubleClick. I'm not sure. I'm mistaken. Either ways, it's well known, MongoDB, and so is Cassandra. Cassandra was sort of started by Facebook. Both are open source databases. So while key value stores are the key and a value, single field generally, that's not, of course, true. If you look at Redis, for example, they can have a whole JSON object, as the value part. But a document store is sort of the same thing. There's a key, and it has to be unique. And then there's a value. The value, again, is a document, typically a JSON document. What's really been happening over the years is these different types of databases, including RDBMs, are all sort of converging towards a sort of a common set of features. So while RDBMs are doing what they do, and they're trying to do some of the things that are beneficial from a NoSQL store perspective, the NoSQL folks started at a certain point. They're not only merging amongst themselves, meaning the key value stores are kind of also becoming like document stores that are kind of also becoming like key value wide column stores, but they're also converging towards databases, right? So I think maybe 10 years from now, maybe I'll be making a video that talks about how this convergence has occurred. I'm not sure, but you certainly see it from RDBMs's perspective as well as from the NoSQL store. So today, as I said, Cosmos DB, document stores, MongoDB and Cassandra, they are nothing but key value stores, but the difference is that in document stores, in this case, like MongoDB, they support ACID transactions, which is not normal for NoSQL stores. And they allow you to index fields in your JSON document. So within a JSON document, you can index on certain fields, including, I believe, arrays, fields that are arrays. And so that helps you speed up the searches, right? So That's different from like in the case of key value stores, you can't index into the value part. You only have the key as the index. Document stores allow you for doing that as well. But there was a time when document stores didn't allow you to index into the document itself. The only index you had was the key. Now they allow you to index into the fields and what any field you choose. Column-oriented databases, or white column actually, they're also called. Databases are like Azure Table Storage, which is, it's like a table, SQL, RDBMs table where you got a key and columns, n number of columns. The columns have no schema. There's a name, but there's not even a name for that matter. It's just, there's no data type for the column. It's just columns. Right? So you can put whatever you want in these columns. And one would say benefits of NoSQL stores is they are schema-less, which basically means that the next row in the same table can have completely different data, not even the same set of columns. So if you were to look at them in a tabular fashion, you might find gaps in certain places for the next record, not because there's no data, it's that the schema itself is different. So white column data stores allow you to have multiple columns, still only one index, and every record could potentially be a different schema. The schema is in your head. It's not like you set it up in the NoSQL store itself. The containers or the tables don't have the idea of a schema, but of course in your application, you may have the notion that this record has this schema and this next record has got the schema. So you can have different schemas for every record in these tables, and you can index on the one field. And that might seem really weird. Why would you want to do that? But there are advantages to having that feature or that capability. And as a result of which you might want to use a white column store rather than a key value store or a document database. Graph databases are actually apart from the rest. Even though they come under the NoSQL store umbrella, they are very specialized. They are very tailor-made and specialized for the notion of graphs, which is like a tree structure, if you will. Not a graph as in bar chart. But they base their sort of engine on what they call graph theory, which is the field of mathematics. Essentially, you have vertices, and vertices have edges that are sort of the joins between the vertices, but they can have multiple vertices between two nodes or vertices. There's multiple edges. So the mathematical terminology is node, vertices, and edges. In database terminology, they call them nodes and relationships. So these are directed graphs, which means the relationships are also directional. So A might relate to B, A being one node, B being another node. In a certain relationship, let's say, A is married to B, right? There could be a relation going backwards, meaning B is married to A, right? And there could be another relationship between A and B that says A loves B, and there could be another relationship from B to A that says B does not love A. Just to give you an idea. So there are directed graphs, and there are many use cases for graph databases where they give you insight into your data that you couldn't have even imagined because of the visualization that you get with all these relationships. You're starting to see connections, maybe 2-3 degrees of separation from where you start, that you would never be able to see in an RDBMS. So graph databases have a specialized use case. If you're looking at like fraud detection, if you're looking at, some people talk about recommendation engines. I'm not sure that recommendation engines are necessarily graph database related, but certainly if you look at LinkedIn, where they say, hey, do you know this person? The way they're recommending that is certainly because of the relationships. Like, somebody else knows somebody else. Therefore, you might know this person who's 3 degrees of separation from you, and they use those algorithms to get there. But they're a specialized case. I don't think they'll ever converge into the other NoSQL stores like the document databases and the key value stores and the white column stores. I think they'll always remain separate with a very specialized use case for that. We're not going to be looking at graph databases today at all. All right, so what is the difference between SQL and NoSQL? So just to be clear here, all the SQL virtues or features are in orange, and the NoSQL virtues or features are in yellow. All right, so let's look at scale. We know that RDBMS scale vertically. What does that mean? It means as you want to support more and more requests per second, you got to buy more hardware. you're scaling vertically. The same machine has to become bigger and bigger in terms of CPU, memory, hard disk space. And there obviously comes a point where either it becomes way too expensive to keep buying more machine, more hardware, or you hit a limit, right? Now, there was a time in the cloud where you couldn't buy or rent large hardware in the cloud. And so you were almost certainly forced into using NoSQL stores if you moved to the cloud. These days, I believe Azure supports, I think they call them the MV2. I'm guessing M stands for monster. Version 2. And it supports like 12 terabytes of memory and 416 CPU cores and unlimited hard drives, like disk space. And these are all SSDs, so they're not spindles. So today, I'm not sure that that's the only. Now, these machines, this one I talked about, MV2, I think would cost you about $16,500 a month, just for the machine. Right? Then, of course, the ingress and egress, as in data going in and out, all that's going to cost you additionally. But that just having the machine up and running is going to cost you $16,500 a month. And of course, if you're a large enterprise, you have that large data set and you need that performance. Yeah, you get one of those machines and you literally don't have to make a change of your existing systems and you can go to the cloud. NoSQL stores, so that was a vertical scale, right? When you have a machine that has 416 cores and can have 12 terabytes of memory RAM and unlimited hard drives, disk space, that's vertical scaling for an RDBMs. Nothing wrong with it. Some enterprises just prefer to stick with RDBMSs because RDBMSs have certain virtues that NoSQL stores don't. So it's not like you can just, because you have this business or this kind of data, you can automatically just go to a NoSQL store and vice versa. There are some scenarios that are more beneficial to NoSQL stores and some that are more beneficial to RDBMSs, and some are in between, and you could do it either ways. And because of your existing skill set and the existing investments that you might have in software, you might decide to stick to RDBMSs. NoSQL stores are built from the ground up to be horizontally scalable. What that means is every node, every machine that's part of the scale out. Think of it as a small commodity hardware. Just as an example, to put a visual in your head, not that that's true, but think of it as your laptop, your desktop, and there's hundreds of these machines that can support your database. But each machine can only support a certain amount of load, right? So it's not like every machine can support a terabyte of data. So it's not about the data; it's about the CPU power and the I/O required to process that much data. So when you scale horizontally, you're really saying that a couple of things. One, the hardware you require, it doesn't need to be this beefy hardware. You don't need 416 CPU cores with 12 terabytes of RAM. They can be smaller hardware that's cheaper. You need plenty of them to support that ability to hold so much of data and to be able to scale or handle so many requests per second, with the idea that the requests are distributed and the workload is distributed evenly, hopefully, across these shards or these nodes. If you haven't seen my database sharding video, please take a look at it here. That might be useful from the perspective of horizontal scaling. Of course, we are talking about NoSQL stores here, not RDBMSs, but it's the similar idea that applies to NoSQL stores. The sharding, if you want to call it that, in NoSQL stores, or the horizontal scale out, is automatic. You're not dealing with it yourselves, but you are specifying what they call the partition key. The partition is that partitioning, why would this data go to this machine and why would this data go to that machine? That partition key is something you decide. And from that point forward, the partitioning happens automatically by the NoSQL store. So they scale out rather than scale up. But they're built from the ground up to scale out rather than scaling up. All right. So indices, now there was a time where RDBMSs, of course, most people know they can support any number of indices. NoSQL stores used to support only one index. Now they're supporting multiple indices. So it's sort of a mix and match. Some do and some don't. So I've just said single because for the most part, that's kind of like how you want to look at it. There's truly kind of like this one index, but you can have other indices, like MongoDB supports indices on the fields inside of the document, and so does Cosmos DB, right? So It's difficult to categorize that, so I've just put single. But there's a difference. There's a limit, and that limit is based on the type of database, your NoSQL store you're using. It's not common. NoSQL started off saying it's NoSQL, then it became not only SQL, and I used to wonder, like, so it's not only SQL, what else is there? Like, I mean, somebody says, I'm not only this, but then, okay, you're not only that, but what else do you know, like, and there's no answer to that. Personally, I think that's a misnomer, this NoSQL store. It's not NoSQL, it should have been no relational store, because that's what they really are. Most of them, all of them, that at least the one that I've worked with and know of, are non-relational data stores. It's not about the NoSQL. They're non-relational. They don't have the idea and the concept of relationships across, let's say, tables. There's no built-in mechanism to support the feature or the need for referential integrity and foreign keys and constraints across foreign keys and such. So there's no relationship. If there's a relationship, it's in your head. There's no relationship inherently built into these databases. So I think the right name would have been no relation databases, not NoSQL. But anyway, it is what it is. So some of these NoSQL stores do support a query language. Some query languages are specific to like by them. For example, Neo4j, which is a graph database, has Cypher as their language. And then there's Gremlin, which is both of them are open source languages, but I think Gremlin is picking up more traction. And so many other graph databases are supporting Gremlin. So Gremlin is seeming to be like the preferred SQL language or dialect. It's not anywhere close to SQL, it looks like. But of course, they're trying to do different things, so the vocabulary will be very different. Cosmos DB supports Gremlin if you're using the Graph API version of Cosmos. So between Gremlin and Cypher, these are more for the graph database aspects. And I think Gremlin is more like a fluent syntax, dot, whereas Cypher is more like an SQL kind of syntax, just like we are used to using SQL and RDBMs. Each has their own dialect, each has their own understanding of what it supports, and some keywords also, that mean something to us in RDBMS worlds will mean or do different things in an NoSQL store. So it's a crapshoot. I think at some point, maybe another 10 years, 15 years, they'll normalize to this one language and there'll be some standards, but for now, there's no standard. Each database vendor supports their own extent of SQL, but it's not SQL in that sense because, again, they call it SQL. They're trying to get there, but they have slightly different meanings for certain verbs, SQL verbs, right? So it's there, but it's fairly limited. NoSQL stores, but I don't have it listed here. NoSQL stores don't have the notion of joining for the most part, right? So the joining is something they don't support, which is why I said there's no relationship, feature in the NoSQL store. It should have been called no relationship or non-relational store database. Joins, it's not like they don't support it. Well, you could do the joins by yourself in your code, right? They don't do it. Now, maybe in future they'll even do that part, but for now they don't support the notion of joins and the notion of relationships across containers or tables, whatever they want to call that. So as a result, the query languages have slightly different meaning, there's no notion of join in these languages, but there are differences. RDBMs have stored procedures. Some databases like Cosmos DB supports store procs. These store procs are written in JavaScript. They have, again, their own language. It's not like TSQL. And they have limitations to what they can and can't do and what they support. But they're store procs nonetheless. There are user-defined functions as well in Cosmos DB, again, written in JavaScript. So they have these ideas, but they mean slightly different things. So they can do slightly different things. Or there may be limitations with what they can do versus what you're probably used to in RDBMS. So even though they're different. Of course, RDBMS are strong schemas, and NoSQL data stores are schema-less. Schema agnostic is probably a better word for it. They're agnostic to schema. The schema is in your head. The schema is in your application. Your application code might be aware of the schema, but the database itself doesn't give you the option to specify schemas or define data types for columns or any of that nature. You can put what the heck you want in every record in your mind. If you want to put this in this container, you want to put only customers here, that's up to you, right? But it's not like it's required. Every record in a NoSQL store database, whether it's white column or document DB or Cosmos DB, I'll talk about Cosmos later. They all support this idea that every record can be a completely different schema. So the schema is something you control at your application. It's not determined or controlled by the database. Now, that is one of the reasons that NoSQL stores became popular. There are many businesses, imagine like the Facebooks of the world or the Googles of the world, right? How do you model a database for something like Facebook or even Google, where you don't know where you're headed, right? It's like every day is a new feature you want to add on. Now you need a whole other set of tables to support this and relationships with pre-existing tables. And it becomes a nightmare. In other words, that strictness, the schema and the relationships and referential integrity and all that is coming in the way of you being able to progress or move faster. So in many ways, NoSQL stores are beneficial to those businesses that have that need. But suddenly one day from the next, you want to slap on new data and forget relationship. And I don't care for the schema. I just want to capture all this data, right? Big data, machine learning. These are areas where you can't predetermine the schema. I mean, if you sat down trying to determine the schema for every one of these scenarios, you probably won't even start writing the code because you just be building out these schemas. So NoSQL stores are really good for those kinds of businesses where maybe within your business, there's a certain component of the data that is schema-less, and that might be useful for you to use NoSQL stores for that portion of the data because it just allows you to sort of store the data, still be able to retrieve it and index it and do the analysis and whatever, but it's not forcing you to define a schema up front and stick to a certain schema. Whether this field have to be there. I don't know if everyone is going to give me that field or not. I mean, I'm not even talking to, it's not my business in the sense that I can't control it, right? It's data coming off the internet, social media. You can't constrain people into saying you must provide me this field and that field all the time. So no schema databases, and that's the reason NoSQL stores were very popular or became very useful during the same era, same point in time when Amazon and Facebook and Twitter and LinkedIn, all these social media websites were kind of getting traction. Graph databases did the same thing. Graph databases also started to take off because social media are one of the larger consumers of graph databases because they can do all this other analysis and find relationships that you can't imagine existed. And it's typically relationships that are not only, so many degrees of separation from the original, let's say person, but coming back up from somewhere else to the person that you were talking about. So you might see one relationship going from person A to B, C, D, E, F, G, but then G might actually have a direct relationship with A for some other relationship, not anything to do with this graph. So anyway, so both these new graph databases and NoSQL stores started to kind of gain traction during that time, and there was like this boom of internet, large companies like Facebook, and Twitter and LinkedIn kind of taking off. Okay, referential integrity. In RDBMs, you can define what you want. It supports it. The database engine manages the integrity of data. The purpose or the way you define your data model in RDBMs is by way of normalization, which is it's the whole intent or purpose is to remove redundancies, meaning duplications, and to prevent update and delete anomalies, which is, like if you duplicate data across your tables, then when you make an update to one area, you have to make sure you update the data somewhere else. So that's the update anomalies in case something has not been updated, it's kind of out of sync. And the delete anomalies are the same. If you duplicated the data in multiple places and you have to delete this one thing, you have to make sure you delete it from other places. So the idea of normalization is, of course, to ensure that you don't have the update anomalies, you don't have the delete anomalies. And the referential integrity is a part of that. In NoSQL stores, there is no notion of referential integrity. So one of the ways you want to look at NoSQL stores as compared to RDBMs is this. Whereas in SQL stores, or RDBMs, the database engine is responsible for maintaining your integrity, maintaining the referential integrity. In a NoSQL store, if you're using a NoSQL store where the data has notions of relationships, which is very common, right? Most of our business data is relational in some way. it is up to your application code to manage the integrity. And that might not make sense, but I'll just go a little bit into this. And of course, in the next videos, we'll go a little deeper into understanding this idea. Whereas in an RDBMS, you're starting your data modeling and doing a normalization, which is you're removing the redundancies. You've got foreign key relationships, you've got constraints, indices, all these things to ensure at any point in time when the data goes into this database, it is correct and clean. And then when you pull out the database, you typically have views that do all the joins, right? And the database engine manages all of that for you. Gives you good query engine as well as gives you a good referential integrity engine. Let's say, that manages your indices and foreign keys and constraints and what have you to ensure the data that goes in, no matter which application puts it in there, is clean and correct. In a NoSQL store, there is no such thing. So the onus of maintaining the integrity, doing queries, of course, now we have, engines nowadays that have some support for query. They're decent, nothing like an RDBMS. And I'm sure that over time they'll get better and better. But the referential integrity idea that RDBMS provide you have to build into your application yourself. Now, I'll tell you why that happens. Because in NoSQL stores, you're primarily not concerned with normalization. You don't care for removing the redundancies. In fact, most times you're duplicating the heck out of your data. So imagine in an RDBMS, when you create a view, let's say you've got these 10 pages in your application, and for each page you've got a view or a query that gives you that data, right? It does all the joins. In a NoSQL store, you want the data to be saved in that fashion because you don't have these powerful query abilities. But if you did that, you've potentially duplicated data, right? But that's what you do in NoSQL stores. Now, that might be shunned upon in an RDBMS world, but in a NoSQL store, there's no problem with that. But now that you've duplicated all this data, who's going to delete stuff when something gets deleted? It's scattered in 15 different tables, right? Like, let's say your customer data is in 15 different tables in your system, which is good, which is a good practice. But now you got duplicated data. So who's going to ensure that there are no delete anomalies or update anomalies? Right? That's up to you. Your application code has to maintain that or manage that. So that's sort of the onus comes on you. This might seem like weird, and why the heck would I ever do that? All I can say is, if your data is such that it works for a NoSQL store versus a RDBMS, in terms of the schema-lessness, if you will, the value. If it's purely relational, you're probably better off using an RDBMS. If it's not, you're probably better off using a NoSQL store. That's not to say that you can't use or should not use NoSQL stores for RDBMSs. Could mean that you need the scale. You need the horizontal scale out, horizontal scaling versus the vertical scaling, or scaling out versus scaling up. That just depends. In this video, I'm not going to tell you which one you should or should not use, but I'm trying to just show you the difference.